Hey, this is Dr. Corey Glenn, and I want to show in this case what one of the things that I really believe is a big advantage in being able to actually use the Blue Sky Bio implants and restorative parts is for digital planning and even creating restorations ahead of time. I'm not saying there's not ways to do this with other implants, but man, it sure is easy when you use the actual Blue Sky Bio implants. So just to take a quick look at this case, this is going to be replacing tooth number 10. As you can see here, the implant has been planned. Patient has lots and lots of bone, so no problem placing it in a nice position to get the good emergence profile with plenty of bone around it. So we've got that there. The surgical guide was fabricated, as you can see here. This is what will guide that implant into the proper position surgically. So anytime you're doing an anterior tooth, it's always nice, if you wanted to be able to generate a very accurate restoration that could be delivered at the time of surgery. That will help train the tissue, that will just really set the case up for success. Again, assuming you've got primary stability and all of the things necessary to do an immediate temp. And so, you could do this. There's ways in Mesh Mixer and whatnot that you could hack this and, use a library tooth and do your own digital wax up and whatnot. But for the sake of this video, I'm going to assume that you have some sort of design software, Exocad, 3Shape, something like that. So let's go to the implant list and turn off the guide tube. Let's turn off the tooth as well. And one of the things that you can do is you can install any of the actual Blue Sky Bio abutments. So in this case, since timing sometimes or the degree of rotation can be difficult to know ahead of time unless you create an indexing jig and all of those fun things, what we're going to plan on doing is using a non-engaging tie base. So if you look on the Blue Sky Bio website, you can see that we have this titanium base abutment non-engaging. This would enable us to fabricate the crown that's going to seat onto this implant in that position, but it doesn't have a hex on the bottom, so you can control the degree of rotation on this. For what it's worth, if you also wanted to use the 1.8 tie base abutment, you could do that and just simply grind the hex off, and that would give you a skinnier emergence profile coming up and out of the bone if you like to play some deep like I do. But let's just, for sake of this, do the non-engaging tie base. Now, you could create an analog holes model with Blue Sky Plan. That would be File, Create Analog Holes, and what it would do is it would now generate a model out of the blue one that you see here that has a place to drop in a Blue Sky Bio, in this case Biomax analog, in the same position, and then you would have a physical model. You could put scan bodies and whatnot on there. But the nice thing again about using Blue Sky stuff is that we don't necessarily have to go to all that trouble. I can simply push replace abutment, and rather than putting that tie base, let's choose a scan body on this. So in this case it's the DES scan body, and I'm going to OK that. And now what you would need to do is go ahead and export this data. So the first one I would do, I would export both the model and this abutment. When you export these together, they're going to become one model. So that would be my scan body model. And then I would also come back and export a second model of just the model by itself. No abutment, no tooth, no nothing. That would serve as just the tissue basis for this. So let's assume we did that. I've already done it here in this case. Let me X out of that. And so I've got those two models on my desktop, and now you would go to your scanning software or your design software. In this case, I'm using Exocad. So I've already designated the case. We're going to do an anatomic crown, as you see right here. I've put in all the specs for everything. It's going to be a screw retained restoration. Just to jump back to that for a moment. You see I've done screw retained, but let's say that maybe I didn't want to go all out and create the final crown or a screw retained crown, but I did want to create a custom abutment ahead of time. The whole one abutment, one time concept, where it's if you could create the perfect ideal abutment to stick on there and then never have to remove it, that bone and that tissue stands the best chance of healing in the best possible scenario. So you could do that. All these options are open to you. But let's in this case do screw retain. I'm going to OK that, and let's now design this. So I'm just going to do a single model. I'm not going to worry about occlusion for sake of this video. And so the first thing it's going to ask me for is the model of just the tissue itself. Okay, so load jaw scan, I'm going to do the one of the model only. And then the next one it'll ask me for is load the model and the scan body. So I'll do that. And now if you take a look at this, you're going to see that we have both options here. One is the just the standard model right here, which is tissue only. The other one would be the model with the scan body in place. And so we need to first define our axis of insertion. So I'm going to get it right in line with that implant. That looks good. And we'll set that as our view. And then click Next. Now the software is going to ask me what implant is it. So if you don't already have the Blue Sky Bio libraries, you can get those for free on our site. You can go there right now and download those to integrate into your Exocad or 3Shape software. So let's go to the Blue Sky Bio. I have all these in here. This is a BioMax narrow platform. And what are we using to screw retain this? So we're going to use the titanium base non-engaging, the one I showed on the website. So now it wants me to define where the scan body head is. So I'll click there and then do best fit matching, and it will sync that up and stitch it into the right place. So now the software has figured out where the implant body is, and now it wants me to define the gingival emergence. So I'm going to do that. We want to create a nice emergence profile for this crown. And then I will go to correct and draw, and I will further refine this. So I want it to emerge nicely up into this area. Okay, sorry, I had a little phone call there I had to answer. But what I'm doing is I'm defining the emergence. I'm figuring out where I want this crown to come out to, thus where you're going to set the tone for the tissue going forward. So I want it to go nicely up into the interproximal. I do want to make sure that looking from the buccal, you don't want to have this thing going way up here and then create the big banana looking crown. So you want to make sure it's within a reasonable contour. And if you play your cards right and develop the tissue in this form, you can get this thing to where the CEJs are going to just perfectly align with the other teeth around this. So let's go with that shape right there. And now we can just roughly define where we want this tooth to be. I'm not going to spend a lot of time trying to do this perfectly at this point because we'll do that in the next step. So now we've got the tooth, and I can go ahead and begin shaping this and trying to get a nice anatomy to it. So first thing I'll want to do is scale it up. Move it over a bit. Let's rotate it. Okay, so now we've designed the crown. I didn't do a perfect job, but it's close enough just to illustrate the point of what we're trying to get across. And so now we're designing the screw hole. We could modify that if needed, but this is already set up for the Blue Sky parts. So I'm just going to click Next. And we have this finalized crown. And so I can right click and save that. I'm going to save this as the restoration. Save. And you want to align it to the original scan data. That's really only if you wanted to maybe pull this into Blue Sky Plan to serve as a wax up or whatever. But now the illustration is I could pull this back into Blue Sky Plan. Let's go to File, Import STL. And let's pull back in the crown, which I just designed. It's going to be a screw retained crown. No need to stitch, so cancel out of this. And I'm going to turn off the guide tubes now, as well as the existing wax up tube, and I'm going to turn off the abutment. Actually, I'm going to change the abutment from a scan body back to that non-engaging tie base, which we actually planned this case with. And so here we have it. You can now look at this in cross section and you can see that this is going to fit exactly back onto that. And essentially you can have this milled. You could even 3D print this, this crown now, assuming that your patient tooth shade lines up with whatever color resin you've got available to print, you know, Next Dent, Crown and Bridge, or MFH. And so this could be printed, milled out of whatever material, zirconia, stained as much as you want, but the point is it's going to be able to develop that tissue perfectly. It's going to be a pre-made restoration. You'll be able to control the timing just by spinning it, and once you crank this down and put the torque on it, the conical engages and you don't have to worry about this thing moving. It is going to be in the right position. And as I mentioned too, this would have probably been a good case just because it is a little subcrestal, and as you can see, a traditional tie base, as is often the case, is going to impinge on the bone a little bit. Maybe use that 1.8 tie base, which we offer, which a lot of companies don't have. And so you can look again, here we go. You can look again at this 1.8. It's got a much more trumpet shape, and if you want to make that non-engaging, you simply just grind off the hex right there and you are ready to roll with a non-engaging hex on that. So I hope you found that useful. I think it's incredibly useful to be able to have restorations ready to go at the time of surgery, or just, you know, final titanium abutments. So hope you found it useful.